This is the first distributive practice in our practice test A, reading for objective 8. It's a limiting reagent and determining maximum yield of product form given the appropriate data. Our question has us reading hydrazine, that's N2H4, it's rocket fuel, when reacts with oxygen to form nitrogen gas and water vapor. Let's turn that into a balanced equation. Now going back, there's no delta H information. This is straight stoichiometry as a distributive practice. The pattern of change has N2H4 hydrazine reacting with oxygen, written as O2, forming nitrogen gas, N2, and water vapor, H2O. Let's begin counting. We have 2 N's, that's set, 4 H's, I'll double the water, 2 O's, 2 O's. 1 to 1 to 1 to 2 balances that equation. How many liters of nitrogen? We want to know liters of nitrogen. When 100 grams of hydrazine reacts with 100 grams of oxygen, what's the maximum yield of the nitrogen in a liter unit given the mass of both reactants? Let's set up what we know. We are given 100 grams of the first reactant, N2H4. We understand we want to know liters. The 3 steps of stoichiometry, divide, ratio, multiply, where our target is liters of N2. We want the liter of N2 given the mass of our first reactant. We also want to start with the oxygen. Given 100 grams of oxygen, let's set up the journey with our 3 parentheses with the same target, liters of N2. We'll carry out the 3 steps of stoichiometry and compare our final answer. We know the maximum yield can be the smaller of the 2 values. The limiting reagent determines the maximum yield. In our first conversion parenthesis, 1 mole of N2H4 needs to be set over the molar mass. 14 times 2 for the nitrogen, plus 1 times 4 on the hydrogen, its molar mass of 32 grams N2H4. Giving us the heart of the problem, the want over given stoichiometric ratio. For every 1 mole of N2, our want, we start with 1 mole of N2H4, our given. We know to land at a liter unit, we use molar volume, 22.4 liters of nitrogen for every 1 mole of nitrogen. We'll hit 100 divided by 32 times 22.4, and my first answer is 70 liters. In my second problem, let's do the same journey but begin with the other reactant, the oxygen. 1 mole of oxygen with its molar mass of 32 grams. The heart of our problem is the want over given stoichiometric ratio. We still want 1 mole of N2 from 1 mole of O2, coefficient of 1 over 1. We will again use molar volume of 22.4 liters in every 1 mole of nitrogen. 100 divided by 32 times 22.4 gives me 70 liters. Coincidentally, if you've noticed, since the molar mass of N2H4 is indeed equal to the molar mass of O2, we've reached the same answer. There is no limiting or excess reagent. Since we calculated 70 for both of them, The maximum yield is 70 liters, giving us no excess or limiting reagent.